The purpose of this video tutorial is to show the workflow for exporting post-tensioning cables from Adapt Builder or Floor Pro back into a Revit model that the Builder model originated from. So we're going to go through this workflow, and we're going to start at Revit, and this is Revit 2018. We have a model built in Revit, and the first step we're going to take is we're going to use the Adapt Revit link, and we're going to export this model from Revit to Adapt. So we'll go ahead under Analyze, I'm going to Export, and we're going to be using the default column parameters, so we can leave this as is. We'll select the option to export the data, and I'm going to go ahead and save the file. So we'll call this MS1, and that has been exported. Now what I'll do is I'll go over here to Builder. This is Builder 17. You'll notice we have Edge and Floor Pro active for this particular example, and also the design scope is set to RC and PT. This gives us the ability to model the post-tensioning. So in the course of designing and analyzing this particular model, we would determine the need potentially for post-tensioning cables. We'll go first to File, and we're going to import generic adapt file. We'll navigate to the file just saved called ms1.imp, and I'll double click that to open it. And you can see under the import options, we want to import mainly just the components, the geometry. We're not necessarily worried about load cases or combinations. Those were not defined in Revit, so they're not shown here. And we're going to use the option to create a new model. Under import level, we want to select all. We'll say OK, and we can see that this file has been created. So if I go and view the file, I can view it in different viewing modes. Top, front, right view for 3D view. This is a plan view of the entire structure. And then we have a couple of side views that we can just navigate and check the integrity of what's been imported. Also, we can go to the rendering tool, which is called View Model, and this is again the file that we have imported. Okay, so now what we're going to do is we're going to just add some tendons inside of one of these levels. We'll go here to level 3. This is a two-way slab, and we'll assume that the user knows how to use this particular program to design the post-tensioning cables. So we'll just model a few cables just so we have something that we can export back into or import back into Revit. So I'll use the tendon toolbar, and I'm going to model just a few tendons. I want to bring my snap toolbar down here. This will help with anchoring these cables, and we'll assume that the banded direction is in the Y direction, the distributed direction is in the opposite direction. So we're going to have we'll start here on this line. We'll create a banded tendon here, and this banded tendon I'm going to use snap orthogonal. It might be anchored, at the wall. It will extend straight over the wall. We have a support point, which is a column, and then another location here where we have a tendon that's straight over the wall. I'll turn off snap orthogonal so I can snap to that point, and I'll go back and I'll edit the tendons just to show how we can edit one or two of these tendons. And we're going to model just one tendon that has multiple strands that are representative of our bands in this example. So we'll go ahead and do something like this. Now we could also do tendon swerving. We might readjust the position of this cable, for example, and I'll go ahead and do that like so, and I might readjust this, move it over closer towards the center of the column. And in this case, we might have a split cable that wraps around this opening, so I can model that particular instance by what I'm going to do is just model this straight through, and then I'm going to add swerve points that allow me to provide the in-plane curvature for the cable. So I'll take this tendon. I can use this option here to insert a swerve point, or I can right-click insert swerve points, and I'll insert a swerve point here and here, and those are indicated by a double green arrow, and you can see we'll just swerve this tendon outside of the opening, something like that. And on the back side, we may want to add a swerve point to align and straighten this tendon out, but this is okay for the example. The same thing could happen here. I'll model another band along this column line. So we have a small cantilever, and then we go into our spans. We have reverse parabola, two reverse parabolic spans, and then a straight span over the wall. And we'll stop at this edge using snap perpendicular again with a reverse parabola. And what I'll do is just copy that. So I'll say Control C, Control V, and I'll copy that over using snap to nearest. And then again, I'll add swerve points. So this time I'm going to delete these 2 points. Those are control points. If I move those, I can move them out. But that means that I have a high point here and a high point here, which we may not want. So I'll delete that point, and I'll delete this point, and I'll replace those with, again, swerve points. So now we'll swerve that out. Okay, and finally we'll go and finish this on this end. Now again, this is not indicative of a completed tendon arrangement or layout. This is just for, again, example purposes for our export back to Revit. But we need to have something in place to show that. So that's a banded layout. And in the opposite direction, I'll add a few distributed cables. So let me go ahead and do that. And you can see if I double click on these bands, I can go in and change the properties. I can change the shape, the profiles necessary to meet my design objectives. Let's go ahead and add a few of the distributed cables. So we'll start using snap to nearest, and in this case the supports are the banded cables. So we'll go ahead and click on supports. Here there's again a short cantilever on this far right side, something like that, and we'll do another cable here. Again, I'm going to snap on the bands or close to the center of those bands. It doesn't need to be perfect, but should be close. Okay, and then I can go ahead and copy that band down. So I'll take this band and I'll go to modify, copy, and let's say I've determined that we want to copy these at 3-foot spacing. So we'll say this is in negative direction, y direction, negative 3 feet, and we'll copy this 10 times. And we'll say copy, and we copied a couple too many times here, so that's okay. I can take this tendon, I'll stretch this back to that slab edge, and then because I have a control point really at the anchor, this blue indicates a low point. It's not a control point. I can't move the cable laterally in the XY plane with this point. I can with this red point, which is the actual control point, but I need to add an additional point. So I can select and add a point, and you can see this point is added here, and then I can move that over to the over here to this intersection with this band. Let me delete that one, and I'll stretch this out. This again is another condition where this beam is actually acting as a support. So one thing here you'll notice, as we get close to these tendons that depart, they diverge from each other, we may need 2 points. So I may have to add an additional control point so that I can control this spread that's going to occur as we move further down the line here. And I'll add one more here, and then move that and slide these and readjust them. So it's easy to readjust the cables, just takes a little bit of time. And then I'll take this and copy this down. We would just repeat this process over the different ranges where we want to add the cables to. So we'll use the 3-foot spacing again. I'll copy those down. So we have some cables in our model. And I'm going to go ahead and just save this model now. I'll call this model also MS1. If I go to a rendering of this particular model, I'll turn off my columns, my walls, and I'll go to a wireframe. I want to scale this vertically so I can see the curvature in the cables. So I'll scale this in the Z. And if I rotate, you can see the vertical curvature. Let me move that down into position here. I think I have it flipped upside down. And because I never went back and actually changed those spans when I added those 2 points where we had this tendon kind of splitting, you can see the default was a reverse parabola, so it just copied that over. I would have had to go through and change those spans. Okay, so we have that in place. And now what we're going to do, let's assume this is our finished product and we want to export that out to Revit. So I'm going to do a little bit of cleanup in terms of what I want to export, the size of the polyline, the labeling of the tendons. So if I go to the tendon toolbar and I use the tendon display manager, I can show the control point heights. I could control number of strands, for example, and I'll just say OK, and the program will produce that data for us on screen. If we want to control the text size, we'll go into the select set view items, and under finite element for tendon, I'm going to change the symbol and the text size, for example. So font size we'll say is going to be 15. That will change the font size. That looks a little large, but we'll leave it as is. And then also I want to display maybe the stressing ends for these cables. On an individual level, I can go into the properties of the cables. Under the stressing option, I can show this is live, so these we can set the ends this way. To graphically display them, I'll go back into my display options and we'll select this option here for stressing. Okay, and that shows the stressing ends. So we'll clean this up for our import. I'm going to turn off the number of strands and we'll do control points and stressing ends. And actually, let's go back and reduce the font size slightly. I'll go back to 10. If I want to change the polyline properties, if I go into a single tendon under properties, you can see I have a line thickness here, text thickness, and so on. I can change the color. Changing the color, we can select this by a group. So I'll go and I'll select by type tendons. Maybe I want this to be a bit brighter, so I'll use a bright green color, for example. And I'll go to modify item properties. And this could also be done inside of AutoCAD if you open the exported DWG file prior to linking it into Revit. And we'll go to outline and fill color, and I'll use this green color here. The line thickness, we're going to make this 5. Okay, that's a little too much. Let me reduce that line thickness for us. So line thickness, let's go back, and I think the default was 3. So we'll use, let's say 3.5. Okay, and then we're gonna save that, and I'm gonna use File Export, and I'm gonna export this as a DWG/DXF. I want to export it as a polyline. If you export it as a spline, then the tendon has no vertical or three-dimensional curvature. It just shows as flat. So we want to export as a polyline to show this as a to show the vertical curvature. And we'll go ahead and just save this file. I'll call this tendons.dwg. And inside of AutoCAD, if I open that file, you can see the file is shown like so. And if I rotate, we should see that curvature. It's easy to see on the short span that has those kinks in it. So this is the file that we're going to link into Revit. And again, you could do some form of cleanup inside of CAD before you link to Revit if needed. So we'll go back to Revit. And in Revit, I'll just turn on wireframe, and we're going to go over here to Insert, Link CAD, and I'll select the Tendon file. And down at the bottom, we want to be able to control the layers that are going to be imported. So I'll select Specify. We're going to use feet as our import units, and positioning, because the exported Revit file is really being re-imported back into Revit in terms of the origin relative to the tendons. We'll just use auto origin to origin. I'll say open, and we can now select, you can see in the background the tendons here, we can select the layers that we want to import. So I'll check none, deselect everything. I'll go down here to level 3. And you can see we have different options here. We have level 3 tendons, control points, and text. So we can control all three if needed. Select OK, and those tendons are now inside of this particular model. And you can see the program shows those live and dead ends, shows control points, and some form of text, which again maybe require a little bit of cleanup here in Revit. Now, if we go to the 3D view, we have the ability, to create a section box. The section box, if we were to adjust this box, for example, and I just create a new plane, and if I go to a new view here, I would be able to see those tendons in section. Okay, so back in the project browser, if I go, for example, to the west section, you can see the tendon marks shown along that edge, and they stop there where we had them. And then in plan view, for example, level 3, this shows me the tendon data as well. That will conclude this video tutorial. If you have any questions, please feel free to contact support@adaptsoft.com. Thank you.